This is question 21 from 2016 AMC 12B. Let's look into it. Let ABCD be a unit square. So let's draw out a unit square, and by unit square they mean it's a square with side length of 1. So each of these sides have length of 1, which is good to know. And we have ABCD, so let's write it out, ABCD. And you know Q sub 1 is a midpoint of CD, so Q sub 1 is going to be right here. That's going to be Q sub 1. Okay, for I equals to 1, 2, and so on, let P sub I be the intersection of A, Q sub I, and BD. Ooh, okay, that's a lot. Let's draw out BD since they mentioned it. Let's draw out BD. And let's look at the intersection. Let's look at the intersection of AQ1 and BD. Okay, so let's look at intersection of AQ1 and BD, which is right this point. And you're going to call this P sub 1. So that's going to be P sub 1. And let Q sub I plus 1 be the foot of the perpendicular from P sub I to CD. So you're going to drop down a perpendicular to CD. And this thing is going to be Q sub this thing plus 1 or Q sub 2. And you're going to continue this process. Draw a line segment from A Q sub 2. And this point is going to be P sub 2. Drop it down. You have Q sub 3. Draw another line segment to find P sub 3. Drop the perpendicular down. You have Q sub 4. And so on. Okay, that's not too easy. It seems really complex at first glance. Let's see what they want us to do. They want us to find sum from I equals 1 to infinity of area of triangle DQ sub I, P sub I. So what are they talking about? Let's look at DQ1, P1. DQ1, P1 is this triangle. Let me shade it. DQ1, P1 is this triangle, the entire thing. DQ2, P2 is this triangle right here. And DQ3, P3 is going to be one around here once we have everything marked. And so on. And you're going to add all of these areas up, and you're going to do this infinite times. Okay. Okay, it looks kind of tough, but how do you find the area of a triangle? The easiest way, and it seems like in this case, since we have everything about perpendicular and you have base lengths and you have clearly defined lengths and you don't really know a lot of angles, the one formula to go for seems like 1f times base times height. Obviously, there are many other formulas to find the area of a triangle, but you know, usually 1f base times height is the first one. Maybe you should try out, and especially in this case. Okay, so let's try to figure out area of DQ1, P1. What's the base? The base is 1/2 because it's the entire length is 1, and you know DQ1 is 1/2 of it. So you have 1/2, which is base, times height. What is the height? That's a good question. Let's try to find this distance, which is the height. So let's call this H sub 1. How can you find the height? And why don't we do this analytically, I should say. Let's draw a coordinate axis. Let's make this X, let's make this Y. This may be one of the easier approach for this case, not for many other cases. For analytic geometry, it usually makes the case worse. But in this case, it looks pretty good. So 0, 1, this point is 0, 1, and this point is 1f0. So you know the equation of this line, you know the equation of A P sub 1 is going to be, or A Q sub 1 rather. Let's make it a longer one. So A Q sub 1. So I'm talking about this line. I'm talking about this line right here. Ooh, that's too thick. Let's use this. Yeah, you're looking at this line right here. Is going to be the slope, which is 1 minus 0 over 0 minus 1/2, which is negative 2x. So y equals to negative 2x. Let me use y equals to mx plus b. And our y-intercept is 1, so plus 1. And you know db, this line, equation is simply y equals to x. So this equation is y equals to x. So what's the intersection? What's the intersection of aq1 and db and y equals to x? So let's solve these two equations together, and you get x equals to 1/3. And since P sub 1, whose coordinate we're trying to find, is lying on the line y equals to x, the x coordinate and y coordinate are going to be the same. So the point we're looking for is 1/3, 1/3. So you know q sub 2 is 1/3 of the distance. So let me redraw this because it's getting very messy. So let me redo this. So q sub 1 is 1/2 the distance, and we just showed that q sub 2 is 1/3 the distance. How about q sub 3? Where would q sub 3 be? We can continue this process forever, but is there a more general way to figure it out once and for all? And that's an amazing question to ask. So let's say you know this thing is 1/a0. So in this case, it was 1/2 0. In the next case, it's going to be 1/3 0. And you're trying to find intersection of the line segment from 0, 1, 1/a0, and the line y equals to x. So the line segment we're looking at, which is a q sub I, is going to be 1. It doesn't have to be a q sub I, but we're assuming that it's going to be 1/a, and you're starting with 1/2, 1/3, so it may continue, and we are going to prove it. We're about to prove it. And the equation is y equals to slope, which is 1 minus 0 divided by 0 minus 1/a, which is negative a x plus y-intercept of 1. And where does this intersect y equals to x? That's when x times 1 plus a is equal to 1, or x is equal to 1 plus 1 over 1 plus a. And this is amazing. Why is this amazing? Because we started with an assumption that you have 1/a0 as our some q sub I, and we showed that next q sub I is going to be 1/1 plus a. So q sub 3 is going to be 1/4 of the way from this vertex. Q sub 4 is going to be 1/5, 1/6, 1/7, and so on to infinite. So how is this helping us? Let's go back to the area problem. For D, q sub 1, p sub 1, it's 1f times 1f times 1/3 because the height is 1/3. For D, q sub 2, p sub 2, p sub 2, our area is 1/2 times, now base is 1/3 and our height is 1/4. And for our q sub 3, p sub 3, let me just do it one more. Our area is 1/f times 1/4 times 1/5, and this goes on forever. So let me sum up all the areas. So you have 1/1/2 times, for the first one you have 1/2 times 1/3. For the next one you have 1/3 times 1/4. For the next one you have 1/4 times 1/5. Then you're going to have 1/5 times 1/6 and forever. And this thing is what they want us to find. So once we find this, we're done. So how can you simplify this thing inside? And you may realize this thing is of the form 1/x times 1/x plus 1 times 1/x plus 1. In this case, x is 2. In this case, x is 3, and so on. And this thing is equal to 1/x minus 1/x plus 1. You can use a partial fraction decomposition to prove this, and I'm not gonna do it here, but because this one is easy to verify. For how can you verify this? By making them have the same denominator. For this one, you're going to have x plus 1 up top. For this one, you're going to have x, and when x's cancel out, you're left with the left side of the equation. So these two are the same thing. So let me see if we can simplify this expression right here. So let me erase this, and this thing is 1/2 times, you have 1/x minus 1/x plus 1 for x sub 2. So you have 1/2 minus 1/3. Then you have 1/3 minus 1/4 because x is 3. And you have 1/4 minus 1/5, and so on. So you have this along infinite. So all of this cancel out, and everything is going to cancel out. And the second term is going to be reduced to 0. It's going to approach 0 as you approach infinity. So the only thing you're going to have left is 1/2. So you have 1/2 times 1/2. So our desired answer is 1/4. So the answer to this question is 1/4.